Ladies and gentlemen, welcome back to the Exchange. To kick off our afternoon sessions, please join me in welcoming Dr. Craig Martell, Chief Technology Officer at Lockheed Martin, for a conversation with Sasha Ingber, founder of Humant and host of Spycast, the International Spy Museum's podcast, to discuss AI and autonomy and its role in defense.
Thanks. All right, Craig, good to sit down with you.
Thanks so much.
You were the first Chief Digital and AI Officer at the Pentagon, so a two-parter to get us started. How did it feel to leave the building, and tell me about your perspective on AI?
Oh, well, the second one's much larger than the former one. So being the inaugural CDAO was pretty fascinating. I had to join together 4 organizations that were sort of on the periphery of what was necessary to do AI. And we merged them together into a single org. And there, I want to praise Jim Ramey because he was a very important partner in my work there. There we focused on a hierarchy of needs. At the bottom of that hierarchy was getting the data right, which, you know, Jim really pulled on. I even like what he said. He said that, I'm not sure what's going to happen with AI, but whatever happens, the data is going to be necessary. I think it's really important that we focus on that. The next level on top of that was analytics and metrics. And those two were really important because in the demand for AI solutions, you'll often see problems that are probably easily solvable by clean data and a dashboard, and an analytics dashboard that might not need magical AI. People just want to know, what's my data say and where's my stuff? And so we really focused on analytics and metrics, because how do you know you're getting it right if you don't know how to measure whether you're doing it right? And note, I haven't said AI yet. That was just clean data and analytics and metrics. And finally, we had AI on top of that for some problems that we thought needed more. And so that's what we tried to drive. And I think we did a really good job of driving that. And you know, I was pretty happy with what Jim said this morning, because it showed that sort of message stuck, although Jim was a leader in that. I'm not saying I did that for him. That was Jim's work. And then leaving the building, since the Pentagon is Lockheed Martin's customer, I will say being in the Pentagon was a wonderful experience. I have nothing negative to say about it whatsoever, and I wish I were still there. You guys can believe that if you want to or not.
Should I ask a question about the shutdown?
Oh, the upcoming shutdown. No, I have no opinion. Yeah. And then the other one was my perspective on AI.
Right.
Is that right? I'm a little concerned by this meeting, and I've been a little concerned by a lot of meetings like this. And here's my concern. It seems like we've all already presupposed the answer to the problem. We have a set of capability gaps. We have a set of desires of things that we need to build. And we have a set of competitive tasks that we have to with our pacing adversaries. But we've already presupposed the answer comes wrapped in a label that says AI. And I don't know if that's true. It might. I've been doing AI for 30 years. This is the best it's ever been. But is that actually the right answer to all of these problems? I don't know the answer to that. And so, again, I really appreciated Jim's comments. I think we should, instead of saying that AI and autonomy plus this, AI and autonomy plus that are going to solve the problems, we should be asking, what capabilities do we need? How do we have to change? And maybe AI is the answer. Maybe some other statistical data-driven solution is the answer. I would like us to be a little bit more open-minded.
You have, in the past, talked about how it's about high-quality data that is representative of the future, and then how do we monitor the model? So let's start by talking about Lockheed's work on Aegis with the Navy and how that has helped destroyers in the Red Sea.
Yeah, that's really amazing. So there's an example of how we ship models out to these ships. There'll be behavioral patterns where we're monitoring how those models do their job. And then we learn almost immediately, almost the same day. and then we'll ship a new model over the air the next day. And so I think that's extremely important. Like, because let's pull the thread about what AI actually is. AI, Brandy's heard this story before, so hi, Brandy. What AI actually is. AI is statistics at scale. That's all it is. We gather data from the past to build a model to predict the future. And that fails under two conditions. It fails if you gather the wrong data, but hopefully we're gathering the right data. And it fails when the future is no longer like the past, when the future changes, right? So the model might work really well for a while, and then it stops working. I'll give you an example. When I was at Lyft, I joined Lyft in March of 2020. So what happened in March of 2020 was the beginning of the pandemic. And the pandemic obviously had a massive impact on rideshare, right? And I did an analysis of all of the models at Lyft, and a third of them hadn't been retrained in over a year. So what does that mean? Well, we quickly retrained them. But what does that mean? That means the data that they were gathered on was no longer representative of the future because the world changed really drastically. And in warfighting, the world changes really drastically. So the more quickly you can gather new data, build new models, and get them to the deployed situation, the better. And so that's what we're doing in Aegis, and I'm super excited about that.
Right, and we're talking about the Houthi-launched missiles and drones and how every day this is improving.
That's right.
Destroyers.
And we're measuring how well we're doing and then changing the model to make sure that we're doing even better and better.
Let's also talk about Fight Club, AI Fight Club, which we obviously love the name. This is another Lockheed.
We can't talk about Fight Club.
Okay, Tyler Durden.
You knew I had to do that joke. I'm sorry. You knew that I had to.
Did you hear that I called you Tyler Durden?
Sorry?
I called you Tyler Durden, right? Isn't
right.
that the name of the guy? But tell us about what this is and why it's an important step as we discuss the evolution of AI.
Yeah, so remember how in the second level of the hierarchy of needs is metrics. We have to be really clear about what it means for a statistically based model, whether you call it AI or ML, I don't actually care. We have to be really clear about what it means for a statistically based model to be successful. What kind of errors are you willing to accept? Are you willing to accept precision errors where or recall errors, false positives, false negatives? You have to make this decision that this is the sort of error envelope that we're willing to accept. And then you have to test whether it's within that error envelope. Well, for many things that we want to ship models for, say planes or surface water vehicles or subs, we actually can't go out and test them broadly in a battle. So we've built the AI Fight Club, and the idea is you bring your models. Lockheed is not bringing a model. This is not designed so that we win and look good. It's creating a metaverse, essentially, where you bring your models into a particular use case, into a particular setting, and we just test them. We let them run, and and the best model wins. And again, we're not gaming this. We're happy to not even have our models run. We want it to be, as best as possible, clear evaluation about how well a model's doing and how the model can get better. I'm super excited about this.
Yeah, and this is government-approved models and simulation tools.
Yep.
And I mean, from what I was reading, it's coastal defense, airborne operations, space-based surveillance, so it's really
There's a lot of different use cases in which we're trying this out, yeah.
Yeah. Okay, so let's move on to Ukraine since our clock is ticking here. We've seen that the Ukrainian forces today have shown that fast and cheap can beat expensive and sophisticated. So do you see private industry working fast enough to fill in that gap here in the United States?
So I find the Ukraine example to be really fascinating. It's really a testimony to the creativity of those soldiers and leaders on the ground. But the question that I have is, just because they build something fast and cheap during war, is that what we should be building for the next war? We have to strike a balance. Like, if we're equipping the folks for the next battle, is it the same taped together solution that they're required to do now, right? So they're doing fascinating things with roles of fiber optics, giving them over the horizon capabilities that they wouldn't have had otherwise. That makes perfect sense in that environment. The question to ask, though, is are we going to replicate that, or should we ask the question, what is quick and attritable look like if we have the time to design it correctly? And so I think it's really important to focus both on those things. How to get things out quickly, but what's the right thing to get out quickly?
It sounds like you're questioning whether necessity really is the mother of invention.
No, I think necessity is absolutely the mother of invention. Now we have to learn what pieces of those inventions are the ones that we have to stabilize and make more robust, and what pieces were just there because of that particular situation, right? Like there's got to be a better solution than trailing a bunch of fiber optic cable. So let's solve that problem so that they have the actual right tool the next time around.
How long does the question period happen before the answers are given and manufacturing moves forward?
Yeah, I think that's a great question, and it's something that I struggled with a lot owning AI for the Pentagon. I think you have to balance the fight tonight with getting it right. And that's always going to be a balance. But let's take a look if we only focus on the fight tonight. For any of you who have been in service, you know that you have 100 tools that they give you, or 50 tools that they give you. Some of them work and some of them don't. So anybody who has ever used the software-defined radio, you know that it doesn't work very well. And it would be great if we could fix that. And every time I talked before Congress, they said, when are you going to fix this radio? Well, the answer is, you won't let us fix this radio because you want the immediate solution now. You want the quick solution now. Well, the side effect of the quick solution now is long-term problems that don't work in the long run. We really have to balance that between figuring out how do we get something out today, and how do we get something out today that may have tech debt, but how do we actually pay that tech debt so we have a long-term stable solution? Now, luckily at Lockheed, my particular job as CTO is looking out 5 years and 10 years from now. Like, what does Lockheed 2030 look like, and what does Lockheed 2035 look like? So I have the probably unique in the company the position of being able to figure out what's right and think about terms of what's right. My job is less about the fight tonight.
And fascinating to think about what the future looks like. If we're thinking about how AI uses data from the past to predict the future, which is not my brilliance, but you said this at one point, crystallizing the idea of what AI needs to be, where do you see AI being most useful when it comes to supporting the intelligence community?
Wow, the intelligence community is from an AI, so I still have professoritis. I don't know if you can see it in the way I talk, but in a prior life, I was a tenured professor. And the intelligence, and I worked for the Naval Postgraduate School, so I was doing a lot of classified work. The AI community is the community that professors like me really want to work with. Why? Because what drives AI? Labeled data is what drives AI. Data from the past where you know what it is. You know what it's supposed to do and what it did do. What does the intelligence community do? The intelligence community, more than anything, gathers data and labels it. They gather data and label it. And it's an AI builder's dream because not only do they gather data and label it, they gather data, labeled it, and digitized it. And then they gathered data, labeled it, digitized it, and organized it, right? So from an AI builder's dream, the intelligence community is ahead of everybody. So remember how we talked about getting the data right? Well, they've been getting the data right for as long as they've been around. And now that it's digitized and organized, they're going to be able to build models more quickly than other parts of the government.
Are you speaking about Project Maven, which started in 2017, working in the National Geospatial Intelligence Agency? Are you speaking specifically about that?
So that's an example of it. So luckily, CDAO had a part in Project Maven, and now that's being run by the NGA. And it's remarkable how quickly they can get data, how well labeled that data is. The NGA is tightly coupled with NRO, so if they need data that's based on satellite intelligence, they can get that right away. So that's a pipeline from data gathering through data labeling through model building that's one of the most robust I've seen. And I think that's true, though, in the intelligence community as a whole, not just for Project Maven.
As we talk about the future, and you say you have to look 5, 10 years from now, what conversations do you expect we'll be having? And is it going to be more focused or mostly focused on autonomous warfare? Is that where this is all really going?
So that's probably the case, right? My guess is, I really liked Eric Schmidt's comments. It doesn't really make sense to put humans out there in harm's way if we can put autonomous things out there in harm's way. So we have to push that level. We have to push that autonomy. Again, I want to drive home the point that whether that autonomy can be done using tool A or tool B should be left open, and we shouldn't presuppose that it's a particular kind of tool. Right? And look, large language models are all the rage, but I've been doing this a long time. There's always a rage, and there's like for a while, support vector machines were going to solve everything, and before that, Bayes' rule was going to solve everything, and so there's always this the most exciting thing. And let's be clear, transformers have transformed my field. There's no question about that. But whether that's the set of techniques that are going to get us to the kind of autonomy we want remains to be seen.
So where do you see humans associating with the machines in wartime as we move forward?
Yeah.
As we're talking 5, 10, 20 years on?
That's a great question. Given that AI is statistics at scale, that means it's guaranteed to be sometimes wrong. It's extremely important you remember that. It's guaranteed to be sometimes wrong. Anybody who's driven in a self-driving car knows in very scary ways it's sometimes wrong, so you better be paying attention to grab the steering wheel, put your foot on the brake. Okay, so I think the most effective human-machine teaming I've seen, and I saw this at Wiesbaden, I think Eric made reference to Wiesbaden, are teams of folks who get the input from I can't give too much away, so I'm just making sure I'm not giving too much away. Has to take the input from a system, from an AI system, and they look, and then a soldier, that input doesn't automatically go into the next phase. A soldier looks at the output of that AI system and says, yes, it's correct. No, it's not correct. Here's the correct answer. And then it goes into the next phase where a system makes another inference, and then a soldier says, yes, correct, not correct. Now, that might seem slow, and there's definitely, you don't want every AI chain to have people interspersed like that. But let's say the system was 80% correct, and humans were 60% correct. Well, humans were 60% correct, or actually, let's let humans be 100% correct, but slow. So humans are 100% correct and slow, and the system's 80% correct. Well, in most warfighting scenarios, 80% correct might not be good enough. So combining the 80% correct system with quick correction by the humans, you get something significantly faster than humans, but much closer to 100% correct. And that sort of teaming, I really think is the right, I know someone pointed out that teaming wasn't the right word, but that sort of working together, it was Jim, yeah. That sort of working together, I really think is the right way to think about this. We don't want to give up our autonomy to a system as a whole, but we need that system to help make us faster. So joining them together, I really think is the right way to think about these things.
And it was actually here with Vice Admiral Trey Whitworth, the director of
I really
NGA.
like Trey, by the way.
We sat down together with CSP for one of the AI conferences in the spring, and he described how they have now started labeling purely AI-generated intelligence so that humans can say, okay, we know this comes from AI, no human touched this whatsoever. So my next question is, are we at risk of becoming too reliant on AI? And as a person who used to work at Lyft, let me just go back in time to the days where I would get in a taxi and people would know where to go. I wouldn't have to give them any directions. And now I get in a Lyft or an Uber and they are absolutely married to the GPS. They have no idea where they're going. So that institutional knowledge that taxi drivers had is gone. I guess I'm thinking about it in the context of war. Again, are we at risk of becoming too reliant? Are we going to go to AI for more than we even should?
So, yes is the answer. I think we're at risk of being too reliant. And let me give you an example. I think because these systems are guaranteed to be sometimes wrong, there has to be what I call a human escape hatch. So let's go back to self-driving cars for a moment, or just ones that are level 3. So a Ford Mustang Mach-E, and when it's on the highway, I can take my hands off, and it drives really well. I'm really impressed. But every once in a while, it gets too close to the car in front of me. Okay, so that makes me nervous. And what if it, and once it actually didn't see a car next to me and almost changed lanes into it. Okay, what was my human escape hatch? First of all, what was my cognitive load that was necessary for me to determine that? As long as I'm paying attention, I could see instantaneously that that lane change was wrong, that was a lane change I didn't want, right? And what was my human escape hatch? I just grabbed the steering wheel. Okay? So as an autonomous human teaming system, self-driving, the level 3 cars are awesome. They're going to get it wrong. They're going to get too close to the car in front of you, and they're going to swerve out or get too close to the truck next to you. Okay, you know that going in. They're statistical systems. They're guaranteed to be sometimes wrong. But the human escape hatch is the steering wheel and the brake, right? And because you know how to drive, if you're falling asleep, that's on you. But because you know how to drive, the cognitive load is very low, very, very low. Let me challenge the large language model producers here the following way. If I have a large language model and I generate some text, so you ask, let's take RAG as an example. You ask a question of a set of documents, right? That's a huge time saver. You don't have to read the documents. I do it all the time using any one of the search engines I use. It comes back on the top, and I've asked a question and I've gotten the answer. Okay. First of all, what's the cognitive load to tell when it's wrong? What do you have to do to tell when it's wrong? Well, you have to read every one of the documents. So I take 10 documents and I throw it into a summarizer, and it gives me a summary. How do I know it got that summary right? I don't. I have to read all 10 documents. Now, I'm starting to develop enough faith that I use it for non-important things. But for important things, I won't use it at all because it's guaranteed to be sometimes wrong. And I can't tell when it's wrong. I can tell when my system called a truck a school bus or a school bus a truck. I can visually look at that in low cognitive load, know the system got it wrong. I'm going to mess up all your phones. When I talk to Siri, and texting my wife, and it says and it transcribes the wrong words, it's very low cognitive load for me to tell it's wrong, and it's only a slight irritant to correct it. Okay? Those are great systems. Those are great ways for humans to interact because I know it's wrong, and I know how to fix it, and it's going to be sometimes wrong. You got to accept that as a premise. And I want to challenge everybody in this room that builds systems. Work harder at making it clear to the user when the system might be wrong. I think this is actually a user design problem, not a AI problem. But find ways to indicate its confidence so that you as a user can dive in and try to find ways to fix it. And do a better job. Look, I don't think it's a good enough job that you just tell me the 10 links that you got this information from. Because nobody goes to those 10 links. Nobody does it. The legalese underneath it says, this could be sometimes wrong, so please verify important information. Nobody verifies the important information. It's too hard. The cognitive load is too great. To me, this is the hidden dirty secret that nobody wants to talk about. And I challenge the producers of these systems to think better, to think harder about what it means to interact with these systems and how you can correct them.
And we have seen, say, in the intelligence community that they'll get information summarized, and then they'll use it to go back to certain places to then read that information. And then they also establish confidence levels.
And they have pointers that say this paragraph came from here, 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 and here. And you can quickly look at them. Like they've done, but that was manual work. And it's massive amounts of manual work. And if we're going to automate that, how do we know that's right? I don't care that it's wrong. What's the cognitive load to determine when it's wrong is the question.
You've also talked a lot about how because these large language models sound fluent, we tend to put our trust in them. They tend to sound reasonable. And that when it comes to our own decisions, we often don't know the decisions we make. So you've made these interesting points in the context of AI, and I'm interested in learning about how your own background in studying philosophy and political science plays into this, and is that why you're kind of going against the grain with a lot of what you're saying here?
I'm not purposefully going against the grain. I'm just trying my best to be honest. It just happens to be going against the grain. But I do think my own background in philosophy and political science before doing a PhD in computer science, I want to give my technical bona fides as well, really had a big impact in the way I think about these things. So if you look at the way humans react to fluent text that these models generate, they react with deference. The output of this text is so fluent and so authoritative in the way it speaks. We react naturally, I think evolutionarily, with deference to that text. Why? Because before 2022, the only things that spoke fluently were human beings.
And if you trained a parrot really well, but sure.
And we trained a parrot really well. That's true. That's a good point. But we don't. I have to think about that. Okay. Aside from that comment, which just messed up my story, the only things that spoke fluently and we could interact with and feel like we were having a conversation with, that's my way out of it, and we could feel like we were having a conversation with, were human beings. And we make the assumptions that human beings reason, and we make the assumption that human beings, except for sociopaths, have engaged in a social contract to tell the truth. If you're having a conversation with me, your expectation is I'm not lying right now, and that I'm actually trying hard to tell the truth. And so, and if I say something that I think is wrong, I'll say, ooh, that might not be right. Let me correct that for you. And that's part of our social contract. So that's what we've been used to engaging with. Those were the beings we've been used to engaging with who spoke fluently. Now we have this new entity in the world, large language models that speak fluently, and we have the same default reaction to it, which I think is fundamentally broken. Because there's no sense of there's no internal state to these machines. They don't know what they're thinking or why they're thinking, and they have no sense of, I'm going to say this, but it might not be correct, so let me tell you why I think it might not be correct. All they do is generate the next most likely token given the prior tokens. And that's fine. That works really well. I'm not opposed to these systems. I'm just saying that we shouldn't defer to them as if they're reasoning beings. We should treat them as statistical systems and put in the sorts of safeguards that I already talked about. Mm-hmm. Sorry for the soapbox, folks. She opened it up for me.
He's going to go blame me, of course.
No, I blame me.
Okay, we've got a minute left here. So last question. With the resignations, with the layoffs at the Defense Department, is there brain drain on AI?
Yeah. So I don't have too much visibility into that, but I will say, let me say this. When I first took the job of the Chief Digital and AI Officer, I asked the following question to the Deputy Secretary. I said, ma'am, why is this a PSA, a Principal Staff Assistant to the Secretary? Why isn't this part of CIO? Because it felt to me AI is definitely the buzz phrase of the half decade, but it felt to me to be a technical solution that needed to be implemented by technical teams. And we'd figure out what the problems were and see if we could solve them. And there were some policy aspects to it. That was her response. There were definitely some policy aspects to it. But I'm not that bothered by the CDAO, for example, moving under R&E, which just recently happened. Because R&E definitely knows how to think about policy with respect to AI. And now all of the AI folks are underneath the same leadership. So let me say that I'm cautiously optimistic that joining those things together allows for economies of scale. All of the folks who are thinking about AI, thinking about it together, from implementation within the building to the research happening at DARPA, that continuum being together, I think, is potentially a really good thing. So let's hope.
Thank you so much, Craig Martell.
Thank you all. Appreciate it.